getting closer. So think of the limiting process. You're getting closer and closer to this value of y equals 4, but can you actually ever get there? So think if I say 3.9, no, 3.99, and how far can you go with that 3.9999? I mean, it goes on forever, where we won't actually ever reach 4 is what this is saying. So there is no maximum value on an open interval where we have a picture like this, right? So we're not guaranteed that there is an absolute max there. And so same thing applies for C, where your maximum occurs at an open interval, or it would occur at that interval, at that endpoint if it was a closed endpoint. Okay, so moving down here, just some vocab to review. I asked the last class, have you guys learned, or do you remember absolute global extrema versus local relative extrema? And everybody said that they learned that in pre-calc honors. That was a solid yes. So I initially had a formal definition here, but instead we'll just kind of informally talk about it. So absolute global extremas would be, if I were to relate it to like the Earth and the real world, it would be the Mount Everest. Okay, so Mount Everest is the highest peak. Okay, so you're thinking like absolute global extremum is the word that you would use when it's singular, and then extrema refers to pluralized. So Mount Everest would be your absolute or your global. So on the globe, that's the highest peak. Versus local relative extrema, actually someone just mentioned Big Bear, but that's the example that I use. It's our local mountains. And so that one is, you have a high peak within a local area. So this is, you're going to think like your local mountains, Big Bear, Mammoth. Okay, so things like that. All right, so that's informally speaking. Now, referencing the graph or the figure that you guys have above there. Okay, we're going to use the letters as our way of identifying our maxes and mins. So in this case, if I'm looking at that picture over on top right here, top right, what would you guys say? What letter is associated? Go ahead and type it into the chat with an absolute max. What letter is associated with an absolute max? Okay, looking at the picture, it looks like B is the highest Y value. That's what a maximum is the highest Y value in that picture. So B is your absolute max. Absolute min, what you guys are thinking about instead of mountains is valleys. Okay, valleys and the lowest absolute Y value. So in this case, the lowest absolute Y value is, what is the lowest absolute Y value? Okay, excellent. It is A. Okay, so the absolute max, I'm going to say it occurs within interval. Okay, meaning it happens somewhere between A and F. Okay, so versus the absolute minimum, A occurs at an endpoint. And that's going to be really important as we move into analyzing absolute maxes and mins based off of just an equation, is we want to make sure that we consider endpoints because it could technically occur at an endpoint. Okay, so we define local relative extremas as values that are the lowest or the highest within that general area. What would you guys say? Type the letters that you think would be local max values, local max values. And it can occur at an endpoint as well. Okay, so good. So I see B is definitely the absolute, but it's within this general area. It is also the highest if you define it that way. So B is a local max, as well as D. Okay, we see that. And F, I would say F is locally to this area right here. Oops, wrong button. Okay, so F is higher than these values to the left of it. So locally for that general region, it's F. If you look at some definitions, if they say open interval, we would just drop off F. But I think if I don't mention F, sometimes the questions will say find your maximums, and students will fail to consider this as a possible max as well. So you do throw it in when considering it. Okay, with that said, what do you guys think is your local mins? What's your local mins? Okay, you guys spelled ACE. I like that. So A, C, and E. Okay, so local minimums are minimums within that general area. All right, so we're gonna go through some of these. I think it's too much review for you guys. So what I'll do is I'll pick the one that I think is the hardest of it to just review some pre-calc honors stuff. Okay, so given the graph of f of x, identify any absolute extrema and local extrema. So on the graph of B, we won't do A, because my Algebra 1 students can do A. But B, you guys have arrows pointing up. So if you guys can make those arrows point up. And if we were asked to find our absolute minimum, where would you guys say your absolute minimum occurs? And when I say where does it occur, can you guys just kind of give me a general value? Where do you guys think it occurs? Just estimate it. Where do you think your absolute minimum occurs? Okay, somewhere between -1 and -2. Good. If I had to, let's just say identify that, let's just say that's -1/2. Good. Okay, so two things I want to emphasize, and I'm going to have us write it out later on in our more formal notes down there. When they say where it occurs, you guys are providing an X value. If they ask what is that minimum value, you guys are going to say -4.5. So in this picture, since we're just kind of informally discussing, this is your absolute minimum value. Okay, you guys, is there an absolute max on this problem? Is there a value for y that I can say is like the highest y value that I can identify on this graph? No. So this is no absolute max. Keep in mind that you guys have no, this is not a closed interval, right? It's an open interval because the endpoints go on forever. Okay, and then lastly, with these other areas, this is a hill. So if it's a hill, that's my local max. Okay, and this is a valley, so this is my local min. All right, so now what I want to do is point out this, this example to you guys. Okay, so that above example didn't have an absolute max. Now, if you guys look below here, do all functions have extreme values? Can you focus in on this graph right here? There is supposed to be an open circle here, and this is arrows pointing down forever. Okay, so do all functions have extreme values? Does that function have a max and or a min? That's the question. Does it have a max and or a min? Okay, so there is no floor or lowest value that you guys see there. So yes, there is no extreme values here. Very good. Okay, and so if you guys explored why, well, I mean, graphically you can see, okay, well, this is a hole here that would have, the maximum would have occurred there. So it's there's a problem there because it's not continuous, right? So we can't make the assumption that there has to be a value there. And then also, you guys have an open interval at the bottom, which is going to cause us to, for this problem, not have a minimum. So the extreme value theorem summarized here, there's two things that are important, right? F of x has to be continuous, and that function broke that. It wasn't continuous at where the max should have occurred. And you guys have to have a closed interval. And when all of those pieces are put together, if you have a continuous function and you have a closed interval, then what we say with the extreme value theorem is that you're guaranteed that you will have an absolute max and an absolute min. Okay, so as an example, instead of drawing one, can you guys look at the middle graph? If I close that x cubed function, first, if I left it open, it would not satisfy this closed interval part, and then we would be left with a function that goes down forever, and then also that goes up forever. So therefore, there would be no absolute max or mins. However, the fact that if I close those endpoints and I have a closed interval, the function is continuous, I'm guaranteed a min and a max value. And that min value would occur here, and my max value would occur there. So, but simply by closing a function and capping out the endpoints, making it defined, will guarantee even a function that normally wouldn't have a max or min will have a max or min. Okay, so let's go into more of the calculus stuff. This so far should be mostly review for you guys. Okay, we're going to talk about something called critical points and values. Okay, so when I'm looking at a function that, let's say you have a function that looks like this. Okay, calculus-wise, we talked about derivatives being the slope of the tangent line. So if I had a tangent line, I can see my tangent line here for this part of the curve is positive, got a positive slope, positive derivative, and then it transitions to having a tangent line that is 0. Okay, and then it goes to negative. And then it goes from negative to 0 to now positive. And I'm talking about slope-wise, right? Slope is derivative. So critical points are these values right here. This is possible maxes or mins. And the word possible is very important. Okay, so critical points or values are possible. Maybe I'll define it a little bit more than just possible maxes or mins. So let's say values of f of x at which a possible max or min occurs. Okay, in parentheses, you guys can write it's where f prime of x is equal to 0. Okay, so that's what you guys see on the graph there. Or let's say I redrew the graph that you guys see there, and then instead of like these nice rounded corners for a polynomial, I have these sharp corners that look like absolute value functions. In the graph that I just drew below that, would you guys say a local max or min occurs? Yes or no? Is there a local max or min in the graph that I just drew? Okay, yes. Would you guys say that the derivative exists at these values? Does the derivative exist here? Okay, the derivative does not exist there because it's a sharp corner, right? The slope changes too drastically, too quickly. So if it changes too quickly and the derivative does not exist, it's still a possible max or min. So we say critical values are where f prime of x is equal to 0 or where it does not exist. Okay, and summarized below there, finding critical values involves you guys first finding f prime of x. Okay, and then 2 steps after that, you set it equal to 0, and you also find where the derivative is undefined. And in most instances, that's when you guys have a fraction and you set the bottom equal to 0. That's where we would have an undefined derivative. Okay, so on example 3, let's try A. Can I have you guys, let's go through this process. So the first thing we would do is find the derivative. So if I can have you guys find the derivative for that. And some of this will be just like, you know, having you guys, practice doing the things that we did in the previous chapter, reinforcing it. And as you guys do more of it in this chapter, I think some of the, things, if it was unclear before to you guys, will start to settle in. You have the whole year to think about derivatives because it's something that is a major theme for calculus. So we're going to carry it through in every chapter. So good, 6x minus 6 is the derivative. According to the process, we set it equal to 0. This derivative function will never be undefined because it's not a fraction. We set it equal to 0. We solve for that and we get x equals 1. So what we're saying is that x equals 1, this is a possible max or min. So in parentheses, this is a critical value. And I want to emphasize because once we move into the next 2 sections, we forget that it's just a possible max or min. It's not guaranteed that it's a maximum or minimum just because it's equal to 0. So this is a possible max or min. And underline or highlight that word, you guys. It's not a guarantee. Okay, and we're going to learn how we can identify that in the next coming sections. So since this is just asking you guys for critical values, that's all we're going to do. Okay, go ahead and find the derivative of the next one. All right, you guys, on the next one, when I take a look at that, and if the definition of a critical value is where your derivative is equal to 0, will this derivative ever be equal to 0? Will this derivative ever be equal to 0? No, this top part cannot be equal to 0, right? So that takes away that qualification for a critical value. However, it is a fraction, so it can be undefined if I set the bottom equal to 0. So with fractions, make sure you guys are identifying all values where you have a possible value that would make your bottom equal to 0 as well. So to solve that, we divide by 3 on both sides to get 0. We cube both sides and we get x equals 0. Or we can just say the only value that would work there to make the whole function equal to 0 or statement or equation would be x equals 0. So x equals 0 is also another critical value. And again, I'll write possible max or min. Okay, so I wanted to do one where it was a little bit more involved. So for C, you guys are finding the critical values for that. So can you guys go ahead and practice your quotient rule on that? I feel like quotient rule, when I was asking people, you guys did just fine on quotient rule. But remember low D high, so x minus 3, the derivative of the top is 2x minus high D low, all over what's below squared. Okay, so here's what I want to emphasize. When you guys have a giant numerator on top where you guys see like a bunch of terms, please simplify that. If you know that you're going to have to set that equal to 0 to solve for the next step, I know we're very used to like not simplifying. If the end purpose was just what's the derivative and it's free response, you stop. However, if it's like you then have to analyze it further, find critical values, find maxes and mins, you're going to want to simplify that expression on top. So that means simplifying out, we get 2x squared minus 6x minus x squared on top. And then if we simplify the top further, we get x squared minus 6x. And why did we simplify? Because then my top, I notice I have an x that I can factor out. And now the expression that I have, x times x minus 6 on top, x minus 3 squared on the bottom, I can see that when I set both of these equal to 0, that it's going to give me multiple critical values. So on the top, just, you know, these are side comments that I see people making mistakes on. Don't forget, you guys, that x is also a factor. So when you set that equal to 0, you get 0. So your critical values are occurs at x equals 0, at x equals 6, and at x equals 3, values that make your top or your bottom equal to 0. Okay, so now how do we take this one step further? What was the point of the critical values? The point of the critical values is to help us identify where there's possible maxes and mins. But now we're going to actually find those maxes and mins. And this process right here, besides the critical values part, is all pre-calc honors and algebra 2 trig. Okay, so it's like find the absolute maxes and mins. What is an absolute max and min? An absolute max and min is the highest y value and the lowest y value. So we just have to find the y values. So all the steps that you guys see down there, it can be summarized as you find the derivative, set top and bottom equal to 0, find your critical values that way, and then now find the largest and the smallest y value, and please consider your endpoints as well. Okay, so let's put that all together in our first problem. Okay, you guys have find the absolute, so highlight that, absolute max and min. So on the AP test, honor free response, if they ask you guys for absolute maxes and mins, you're going to notice that they have a closed interval here. So we're going to take that and let's see, I'm just paying mine too. I have 8 minutes with you guys. Okay, so what I would do is when I see that, create table of values. So think back to algebra 1 even. Okay, you guys are creating a table of values. You want to identify the highest and the lowest y value. So we're going to create a table of values, keeping in mind that we have to also consider 0 and 6 could be a possible max or min. Okay, then we need to find all the values in between. All our possible local maxes and mins are going to be found by finding the critical values, right? So take the derivative. We have 6x squared minus 30x plus 24. Okay, notice there's a 6 in everything. When I set it equal to 0, I'm going to factor out the 6, get minus 5x plus 4, factor further, and get x minus 4, x minus 1, with the critical values being 1 and 4. Okay, so with this, you guys, normally, I would say if it's a simple polynomial equation, they might just have you guys find the y value by hand. However, if it's on your homework assignment and you guys understand the process, I'm fine with you guys finding the y values of 0, 6, 1, and 4 on your calculator. Remember, the quick way to do that is to enter in y1 equals your function. So this goes into y1 on the calculator. Then you guys go back to your home screen, and then you do the bars and do y1 of 0. You do y1 of 6, and then find each one of the y values. And so if you do that, let me jot it down for you guys, and you would get 7 for 0, which that one we didn't have to use the calculator for, 18, -9, and 43. You're going to look at your table of values, make an assessment, and see that your lowest y value occurs at 1 and is -9, and your highest y value is 43 and it occurs at 4. I'm going to write that out because that's important for us to be able to explain that eventually. So absolute min always occurs at an x value. So occurs at x equals 1 and has a value and min value of -9. And if you guys can write the same thing for the max, so absolute max occurs, and sometimes the question just asks you guys, where does it occur? And sometimes it just asks you guys what the value is. So it's important that you guys can distinguish between the two. And so I have you guys just write that sentence just in case on a free response they ask you guys one of the questions. This answers both of the questions, where it occurs and what it is. All right, as our last problem, we have just enough time for it. Example 5, can I have you guys find the derivative and then find the critical values for me? I'm going to start with just the table of values. I know this is a absolute max or min question because of the closed interval that was provided. So I'm going to put the endpoints here so I don't forget I need to assess those two. So once again, when we take the derivative, the 1 is a constant, so it's 0. Then the negative times the 2/3 is -2/3 out front. X minus 1 to the -1/3, because we subtracted 1. Don't forget, chain rule is technically applied to the derivative of x minus 1, which is just 1. So we get that our final derivative is that when I rewrite it. And I encourage you guys to rewrite negative exponents as a fraction, put it under. We see that this is not going to be equal to 0. So my top, I don't have to worry about. My bottom, when I go to solve for it, I divide by 3 on both sides, which is still 0. Then I cube both sides, which is still 0. So it's really x minus 1 equals 0. My critical value occurs at x equals 1. So you guys can see that in the graph that that's true. X equals 1, you have a critical value. So on my table of values, they expect for you guys to find the y values of each to assess. Let's say you guys didn't have a calculator for this one. And I can see this being a non-calculator question, even with -1. So let's go ahead and plug everything in and let me explain why. Okay, let me do the from the bottom up. When I plug 1 into my original function, I get 1 minus 0 to the 2/3, which is just 1. Okay, when I plug 2 in, I have 1 to the 2/3 that I have to evaluate, and that's 1 squared cube root of 1, which is just 1, or 1 to the 2/3 is 1. So 1 minus 1 is 0. And then I get to -1, and -1 is not so nice. When I simplify inside the parentheses, I have -2. -2 squared is 4. The cube root of 4 is not a nice number. So you have 1 minus the cube root of 4. Okay, so if I take the cube root of 4, I'm going to get a number that is going to be higher in absolute value than 1. So 1 minus the cube root of 4 is technically a negative number. So if I look at that all together, you guys have that you have a negative y value, you have a 0 for at x equals 2, and then you have a 1. So if I had to identify what my absolute maxes and mins were, this is a positive 1, so this is going to be my max. And my lowest value is a negative number. So I would say, summarized on the right, my absolute min occurs at x equals -1 and has a value of y equals 1 minus the cube root of 4. Okay, and then go ahead and summarize your max as well. Just having you guys do this so that it becomes a force of habit for you to write out and explain, because this is going to be really important in this chapter, and has a value of y equals 1. And we are going to end here.